Well, good morning, everyone. We are going to go ahead and try this method of education. So we'll see what happens if you hear strange noises. It's because my cat is in here trying to help me. So what we're going to do is skip to chapter 7, and we're going to look at the multiplication properties of exponents. Hopefully some of you have already run across this in your work with Alex, but we'll go ahead and get started. Now, you should have your notes that I had available to you on the lesson plans. So I would encourage you to take notes just like you would if you were in class. At some point, I may get you to send me a screenshot of the notes that you've taken so that I can see that you have been participating in class. So we first want to start by determining what a monomial is. It's a number, a variable, or product of a number or variables. And it's only one term. There won't be any pluses or minuses. For example, x to the 3/2 y squared z, even though you've got several terms within that, is still a monomial because everything is multiplied together. Now, 3y over 2x is not a monomial because we're dividing by a variable. We do not divide by variables with a monomial. So with a monomial, the only application that's possible is multiplication or raising something to a power. A monomial that is a real number is a constant. A monomial that is a real number is a constant. So if we look at the next little section and we want to determine which ones of these are monomials, is the first a monomial? No, it's not, because we are dividing by an x. So this is not a monomial. What about 4x squared? There's no addition, no division by a variable, so yes, this is a monomial. What about 3x squared plus 7? Because we have this plus sign, it is not a monomial. Here we have 4/3 xyz. Notice there's a difference between 4/3 xyz and 9 divided by 2x. 4/3 is a constant, but we are not dividing by a variable, so yes, this is a monomial. Now let's look at this example that I have next. We are doing 2 squared times 2 cubed. Now if I were to write that out in expanded form, we would have 2 times 2, which accounts for the 2 squared, and then we would have times 2 times 2 times 2. This accounts for the 2 cubed. Now how many times is 2 a factor? We see that 2 is a factor 5 times. And notice if I add the 2 plus 3, those exponents, we get 2 to the 5th. So if we have the same base, and both of those factors have exponents, the base has to be the same. This does not work. It would not work if we had 2 squared times 3 cubed. But since it's 2 squared times 2 cubed, we can add the exponents and we get the correct answer. And some of you may know that 2 to the 5th is actually 32. It's a good idea to know those powers of 2 up to at least 6. So if I look at the next problem, we just have we're not using a number for a base, we're using a variable for the base. But the same thing happens. I would have, for the x to the 5th, we could look at that. If we expand it, it's x times x times x times x times x. That takes care of x to the 5th. And then x cubed is x times x times x. So how many times is x a factor? X is a factor 1, 2, 3, 4, 5, 6, 7, 8 times. And again, we see that if we add 5 plus 3, we get x to the 8th. So if we wanted to come up with a rule for the product of powers, we could say that if you have the same base, then we add the exponents. And we just looked at two examples that prove that if we have the same base, we add the exponents. For instance, b to the 3rd times b to the 4th would be equal to b to the 3 plus 4, or b to the 7th. All right, now let's look at something that's a little bit different. Notice here I have two monomials that I'm multiplying together, and if we have to do a little bit of grouping, because with multiplication we can use the associative property. We can reassociate. So I associated the constant terms, and notice the bases are the same. So we have 6 times 2, and we have n to the 3rd times n to the 7th. Well, we know that 6 times 2 is 12. We multiply the constants together. And because I have the same base, n, I can add those exponents, and n to the 3 plus 7 is n to the 10th. So this is really a pretty relatively easy process. If we look at the next one, we're going to have 3 times 7, and then we have y to the 4th times y to the 5th, which is 21. Y, 4 plus 5 is 9, so 21 y to the 9th. Let's look at this one. We don't have a constant in front of the r, so a 1 is understood, but we would have 1 times negative 12, which is just negative 12, and then we have r to the 4th times r to the 3rd, and that's a 4, which is negative 12 r to the 7th. Okay, I'm going to give you a minute. Actually, let's just do about 30 seconds. Let's take 30 seconds and you do the next problem, this problem. Okay, hopefully you were able to get that. 6 times 5 is 30. C to the 1st times c to the 5th is c to the 6th. And d to the 5th times d squared is d to the 7th. Remember that if there is no exponent showing, that a 1 is understood to be there. So you should have gotten 30, c to the 6th, d to the 7th. All right, let's do the same thing with the last problem in this section. I'm going to give you 30 seconds, and I want you to work this problem. Okay, let's take that 30 seconds and start. I don't know if you can hear it. My cat's over here purring. He's happy to have his mama home. Okay. Here we're going to have -4 times -6. A negative times a negative is a positive, so -4 times -6 is 24. R to the first times R to the fifth is R to the sixth. X squared times x squared, we add the exponents and we get x to the fourth. And t cubed times t, remember, a 1 is understood where there is no exponent showing. So we have t cubed times t, 3 plus 1 is 4, so we get t to the fourth, 24, r to the sixth, x to the fourth, t to the fourth. Okay, now we're going to look at a monomial raised to a power. 2 to the fourth is a monomial. And so if we raise 2 to the fourth to the second power, that means we're going to have 2 to the fourth times 2 to the fourth. And we know how to solve that. 2 to the 4 plus 4 is 8. Now I want you to take a second and think about what happens if I multiply 4 times 2. Notice we get 8. If I look at the next problem, x cubed squared, a monomial raised to a power, is x cubed times x cubed, which gives us, we add the exponents, x to the sixth, but notice that when I add the exponents, it's the same here as if I had multiplied these two exponents. So you've just seen an example of the rule for a power of a power. To find the power of a power, we multiply the exponents. For instance, if we have, if we have b cubed to the fifth, that's b to the 3 times 5, or b to the 15th. And it doesn't matter whether the base is a constant or the base is a variable. If we had 2 to the 5th squared, we get 2 to the 5 times 2, which is 2 to the 10th. So let's work through, I'm going to do a couple of examples, and then I'm going to let you try a couple. Well, here's this one's already worked out for you. Notice this looks a little bit more complicated than the last ones, and isn't that always the way it is? But we can start in the middle, and we work our way out. So notice I started with these two first. 2 to the 3 times 2, and that's still raised to the 4th power. So we have 2 to the 6th. 3 times 2 is 6 raised to the 4th power, which is equal to 2 to the 24th, because 4 times 6 is 24. Notice it's not that hard. Start from the inside and work your way out. Okay, let's look at this example. Remember, I said let's start on the inside and work our way out. So we're going to have 2 cubed cubed. That's 2. 3 times 3 is 9. Now notice that's still all squared. So we're going to have 2 to the 9 times 2, which is 2 to the 18th. Okay, let's look over here. X to the 5 times 2. And then if we raise that to the 10th power, 10 times 10 is 100. We get x to the 100th. All right, let's look at the next one. Notice this is a little bit different. Here we're going to have, if we were to write this in expanded form, we would have TW times TW times TW. Or we could say we have T to the third times W to the third. Notice there's no exponent, so a 1 is understood. We multiply the x by both exponents. 3 times 1 is 3. Let me do a different color here. 3 times 1 is 3, and 3 times 1 is 3. Same thing over here on the next problem. We're going to have 2. 1 is understood. If you need to, write a 1 there to remind you. 2 to the 3 times 1, y to the 3 times 1, and z to the 3 times 2, which is 6. Now 2 to the 8th, I expect you to know, and I would want you to simplify that to 8y cubed z to the 6th. Anytime you have something easy like that, 2 squared, 5 squared, even 5 cubed, I would like to see the actual number that is, and not just leave it as 2 cubed, because you guys are high school. This is Algebra 1, Math Models. You should know how to raise those to an exponent. Now we need to know when to stop. So we need to know when is a monomial totally simplified. It's simplified when each variable appears only one time. It's simplified when there are no powers of powers. In other words, you can't have x squared cubed. And all fractions in simplest form. I don't want decimals, but I do want you to reduce fractions to simplest form. For instance, 24/32 would not be simplified. You need to simplify that. And if we look at this, we know that 8 goes into both of those. And we get 8 3/4. So 3/4 is simplified. 24/32 is not simplified. All right, I'm going to work this one out, and then I'm going to have you try a couple of them. We'll check it and before you start doing work on your own. All right, let's look at this one. Notice we're going to have 3 squared because there is no exponent, so a 1's understood. There's a 1 understood here. X to the 1 times 2 is x squared. Y to the 4 times 2 is y to the 8th. Now that takes care of that first term. Let's look at this second term. We're going to have -2 squared. Now that, and I'm writing it this way because what happens when we square a negative number? That's right, it becomes a positive. Y squared, I took care of the inside first, and now I'm going to take care of the outside. I'm going to go ahead and change this to a 9. 9x squared, y to the 8th, times, what's -2 squared? 4, and I'm going to multiply 3 times 1, which is 3, and y to the 6th. Okay, I'm going to go ahead and simplify 4 cubed is 64, y to the 6th. So now we have to multiply 9 times 64, which is 576. Yes, you can do that. If you have a calculator handy, you can use your calculator on that. Do we have another x? Just this one, so it's x squared, y to the 8 plus 6, which is 14. So now we are totally simplified. Okay, now here I have another one. Don't freak out because of the fractions. I do want the answer. I want you to work this out as a fraction, not a decimal. You may use a calculator, But take about 30 seconds and see what you can do with this problem. Go ahead and start, and let's see what you can do with that, and then we'll work it together. You can check your answer, but I want you to work it out to see if you are getting the gist of this. Okay, let's look at this. We take it step by step. We're going to have 1/2 cubed. We're going to have a to the 6th, b to the 6th. And then we're going to have -4 squared, b squared, and all of that is squared. So 1/2 cubed is 1/8, a to the 6th, b to the 6th. You cube the numerator, 1 cubed is 1. You cube the denominator, 2 cubed is 8. -4 squared is +16. If you have a negative number raised to an even exponent, the answer is positive. If you have a negative number raised to an odd exponent, the number's negative. B to the 2 times, and then b squared. And all of that is squared. So we get 1/8. I'm just going to repeat what I had. A to the 6th, b to the 6th, and I told you you could use a calculator.